Imagine a problem so complex that it would take the most powerful supercomputer we have today millions of years to solve. Now, what if I told you that a different kind of computer could potentially solve that same problem in just a matter of minutes? That's not science fiction. That's the promise of quantum computing. So, what is this incredible technology and how does it work? Let's break it down together. First, let's talk about the computers we use every day, from our laptops to our smartphones. These are called classical computers. They work with bits, which are like tiny light switches. A bit can either be off, which we represent as a 0, or on, which we represent as a 1. Every photo you take, every video you watch, and every message you send is ultimately just a very long sequence of these zeros and ones. It's a simple, reliable system that has powered our digital world for decades. But this simplicity also creates a limitation. For certain types of problems, the number of possible combinations a classical computer needs to check grows exponentially, becoming too vast to handle, even for a supercomputer. This is where quantum computers come in, and they play by a completely different set of rules, the rules of quantum mechanics. Instead of bits, quantum computers use something called qubits. Now, this is where things get really interesting. A qubit isn't just a 0 or a 1. Thanks to a principle called superposition, a qubit can be a 0, a 1, or both at the same time. Think of it like a spinning coin. While it's in the air, it's neither heads nor tails. It's a mix of both possibilities. Only when it lands does it settle on one state. A qubit is like that spinning coin, existing in a combination of states until we measure it. This ability to be in multiple states at once is a game changer. If you have one qubit, it can represent two values simultaneously. With 2 qubits, you can represent 4 values. With 3, you can represent 8. As you add more qubits, the processing power grows exponentially. A quantum computer with just a few hundred qubits could hold more possible states than there are atoms in the entire known universe. This massive parallel processing power is what allows a quantum computer to explore a huge number of possibilities all at once, which is why it can solve certain problems so much faster than a classical computer that has to check each possibility one by one. Now, let's talk about another bizarre quantum phenomenon called entanglement. Albert Einstein famously called it spooky action at a distance. When 2 qubits are entangled, they become linked in a special way. Whatever happens to one instantly affects the other, no matter how far apart they are. If you measure one entangled qubit and find it's a 0, you'll instantly know its partner is a 1, and vice versa. It's like having a pair of magical coins. If you flip them and send one to the other side of the galaxy, the moment you see that yours landed on heads, you know for certain that the other one landed on tails. This interconnectedness allows for even more complex computations and information processing that are simply impossible for classical computers. So what kind of problems are we talking about? Quantum computers aren't going to replace your laptop for browsing the internet or writing emails. They are specialized machines designed for very specific, incredibly hard tasks. One of the biggest fields is drug discovery and materials science. Designing a new molecule for a medicine is incredibly complex because you have to simulate how all the atoms and electrons will interact. A classical computer struggles with this, but a quantum computer, which operates on the same quantum principles as the molecules themselves, could simulate these interactions perfectly. This could lead to revolutionary new drugs and materials created in a fraction of the time it takes today. Another huge area is optimization. Think about complex logistics problems, like finding the most efficient delivery routes for a global shipping company, or managing a city's traffic flow in real time. These problems have an astronomical number of variables. Quantum computers could sift through all the possibilities simultaneously to find the absolute best solution, saving companies billions of dollars and dramatically reducing our carbon footprint. They could also revolutionize financial modeling, helping to better predict market fluctuations and manage risk. Then there's the field of artificial intelligence. Quantum machine learning could enhance AI algorithms, allowing them to learn from data in new and more powerful ways. This could accelerate the development of more sophisticated AI for everything, from medical diagnostics to climate change modeling. Scientists could use quantum computers to simulate complex climate systems, helping us better understand and combat global warming. Of course, building and operating a quantum computer is incredibly challenging. Qubits are extremely fragile. The slightest disturbance, like a tiny vibration or a change in temperature, can cause them to lose their quantum state in a process called decoherence. This is why quantum computers need to be kept in highly controlled environments, often at temperatures colder than deep space, and shielded from the outside world. Scientists and engineers are working tirelessly to create more stable qubits and develop sophisticated error correction techniques to make quantum computers more reliable and scalable. We are still in the very early days, much like the 1950s for classical computers. The machines are large, expensive, and require a team of experts to operate. So, while we won't be buying a quantum MacBook anytime soon, the progress in this field is accelerating. Companies like Google, IBM, and many startups are in a race to build more powerful and stable quantum machines. What this technology represents is a fundamental shift in our ability to understand and manipulate the world at its most basic level. It's not just about building faster computers. It's about unlocking a new era of scientific discovery and technological innovation. From creating life-saving medicines to solving our planet's biggest challenges, quantum computing has the potential to reshape our future in ways we are only just beginning to imagine. It's a journey into the strange and wonderful world of the quantum realm, and it's a journey that has just begun. Thank you so much for watching. If you found this explanation helpful and are excited about the future of technology, don't forget to hit that like button and subscribe for more deep dives into the science that is shaping our world. Let me know in the comments what you think the biggest impact of quantum computing will be. See you in the next video.